comes out in a few weeks, they can start using it immediately. We're going to start by doing a brief review of what's new in the software. What is new? First off, one of the major new features is what we call the hybrid load splitter tool with precision peak shaving. It's designed to really enhance the accuracy and ease of design of a hybrid system. In addition, we have a new hybrid graphing suite that makes it very easy to visually understand. Jeff, I'm still getting a lot of feedback from some of the participants. Can you mute the other ones who haven't muted their microphones?
Yeah, I've got everyone muted.
I'm sorry, what? Oh, great.
I said I have everyone muted, Dan.
Okay, great, thanks. So that's the first feature. The second feature, as I mentioned a moment ago, is what we call our advanced hybrid graphing functionalities that allows the user or the designer to quickly just visually understand the relationship between the geothermal loads, the hybrid loads, etc. And then in addition to the hybrid design tools, we've updated the lifecycle costing tool to account for the new hybrid design methodologies to really do a more accurate assessment of the cost of operating a geothermal hybrid system. We've added a new fluid database into the fluid dynamics module that enhances the accuracy and range of functionality of that module. For those of you that don't know, the CFD, or Computational Fluid Dynamics module, is a tool that makes it very easy to basically optimize your piping design of your heat exchange system for both purging applications and daily operational applications. And then we have a new pipe database in the program full of a whole range of international pipe sizes. A lot of our international customers have been asking for this for a long time. We have that in here now. And then updated reference files. These are the major new features. There's a whole bunch of other things going on, but I'm not going to mention most of them. I'm going to run out of time. So let's take a look. Let's look at the new hybrid load splitter tool. What it does is the following. First, what it does is precision peak load shaving on 8760 hourly loads profiles. So if you as a designer have hour-by-hour heating and cooling loads data, which we consider to be the gold standard for designing loop fields these days, then you can really do precision load shaving. We also have intelligent, independent peak and total load shaving on design day and monthly loads profiles. These are different loads profiles that you can use in GLD. Then in addition, what we have is fast, direct hybrid design without the need to use any external programs such as Excel for iterative load modification. In previous versions of GLD with the hybrid tool, we recommended people do this work using GLD and Excel, and it took a while, but now it's all integrated into GLD, and it's very, very fast. More specifically, in previous versions of GLD, the hybrid tool was an estimation tool that cut both the annual and the annual and cumulative load equally. It was recommended that the designer estimate the peak load cut using the sliders in the program, and then cut that peak from an hourly loads profile in Excel and bring it back into GLD. It was a long, sort of iterative process to maximize accuracy. And this is kind of what it looks like visually. You might get some preliminary numbers in the software, performance numbers for a design, and then with an estimated slider of 25% here on the cooling side. Then you take the loads into Excel and manually manipulate those loads to cut that 25% load, and then you import that modified load into GLD, and then do a new design. You see your new design, your numbers come out differently. This is how we recommended people do it. Now, with GLD, you can do this whole process in about 10 or 20 seconds. It's much, much faster. It's really, really nice. The new hybrid design tool, among other things, shows you how the loads change as you use the sliders. So for example, in the 2012 edition here, regardless of whatever you did with the loads sliders, the hybrid sliders, the loads displayed would not change. We can see the loads here. With the new edition, the 2014 edition, when you do use those sliders, the hybrid design day loads panel becomes active, and you see that the loads are modified. You can actually see what's happening in real time to your loads. So the new hybrid design tool substantially increases hybrid design speed because first, in real time, it parses and updates hourly and monthly loads profiles. And second, the updated loads profiles can then be used for loop field design and performance simulations. The process is fast, easy, and straightforward, and in a few minutes we'll be doing a few samples to kind of demonstrate that. So to take full advantage of the new hybrid tool, designers should be using 8760 hourly heating and cooling loads profiles. As you may know, each and every building has a unique energy and loads footprint. One can predict this footprint by properly using one of the 8760 hourly energy simulation tools that are available on the market. So a few examples: eQuest, Train Trace, CareHap, eQuest, it's the IESVE, there's a range of them. And this is really the gold standard that we see people using these days. If you don't have 8760 data, the new hybrid tools still are much more powerful than the old one, but you just can't take full advantage of them. So here's an example of an 8760 hourly loads profile. We have on the y-axis the load per hour, kb2 per hour. On the x-axis we have hours from hour 1, which is January 1st, like at midnight, and then 8760, which is December 31st at 11 p.m. You can see the heating load in red and the cooling load in blue, and you can see for each hour of the year we have an idea of what the loads are going to be. Now these hourly loads data are invaluable for hybrid design because they enable us to know when the hybrid system is predicted to be active each hour of the year. For example, here we have a July 31st loads profile, and we have an August 1st loads profile, separated by 1 day. And July 31st, with the hourly data, we see where this light blue color is. That's where the hybrid system's turned on this day. But on August 1st, it's only a few hours that it's on. So there's a substantial difference from day to day when the loads are going to be active. I mean, the hybrid system is going to be active. And we really need to have hourly data to come up with a good understanding of when that's going to be. Knowing when the hybrid system is predicted to be on and off on an hour-by-hour basis enables you as a designer to first accurately predict the peak and total energy loads going into and coming out of the ground. Second, to properly size the loop field for your target entering water temperatures. And third, to optimally determine the system economics. We're going to see some very interesting things in a couple minutes on that. With the detailed loads information and the upcoming release of GLD 2014, optimized hybrid sizing has really never been more accurate, faster, or easier. Let's take a look. So let's assume we've imported this hourly loads profile into GLD. And then we're going to design a system based on the hourly loads. We've imported the loads into our average block loads module. We have hourly data here. We've selected a heat pump, 4-ton heat pump. And we've designed a system. We have 60 boreholes, 300 feet deep. We have our predicted temperature range over 15 years of about 84 on cooling and about 50 on heating. Very reasonable. But so far, we haven't used a hybrid system. Currently, the sliders are set at 0 and 0. You may note that this panel looks a little different than previous editions of GLD hybrid sliders because it is new. What happened? So with an 8760 hourly loads profile, GLD automatically calculates the new hourly loads profile each time the hybrid slider percentage is adjusted. So for example, if we adjust the cooling slider to 10%, we're going to do a detailed peak slicing of 10% of the total load, and we hit the update button. What happens is, within the program, we're looking at our hourly loads profile. You see this green line here. This is basically 90% of the peak cooling load. So everything above this green line here, the program is automatically cutting and assigning to the hybrid mechanical system. So it's just doing something like that. And here's another way to look at it. We have our original cooling loads in blue going all the way there. Then we have our geo-cooling load after the hybrid slice in red. And then this green lines down here is basically the hybrid load. So this is the red line. The red lines are the geo load, and then the red line and the green line is the hybrid load, and then the cumulative is the blue. So you can see kind of how this is divvied up. So when you do use those sliders, the modified design day loop field loads are displayed, and heat pump performance is automatically updated. So on the left, we don't have any sliders at all. And we see our baseline loads here and our baseline heat pump selection and performance. And then here, when we're using a 10% cooling slider, you notice that the loads have been updated. Previously, the loads on the cooling side looked like this. Now they look like this with the 10% slider. And the capacity of the pump has changed as well. In this case, mainly in terms of the flow rate, because the load is smaller. It's 170 GPM here as opposed to 189 from before. Additionally, the monthly loads are also automatically updated as well. So in a baseline example here, here's our baseline monthly loads profile. We have not used any sliders yet. And then when we use a 10% cooling slider, we notice that in these months, the peak cooling months, summer months, June, July, August, etc., the peaks have all been shaved down to 680. Here it's basically 702, 756, 708, but the program's determined based on this 10% selection and the hourly data that these 3 months are going to be decapitated, basically. You'll notice the peaks have been decapitated, flattened out here, and the monthly totals for those months have changed as well, although it's not a significant change in this example. Like, for example, for July, it goes from 128,982 to 128,129. So not a big difference, but it is done automatically in this example. Now this is where it gets pretty interesting. We start looking at some of the graph functions inside the new tool. Again, in this first example, we don't have any sliders active at all. And you see basically our total cooling load is in blue and our peak is in green. This is our peak in green. If I do a 10% slider, you'll notice my peak load has been decapitated a little bit right at the top. And then that 10% that was been decapitated from the top is now down here going into the hybrid system. My total loads haven't actually shifted that much. This is my total cooling load for Geo. My total cooling load for on the hybrid is this dotted line you can barely see, because essentially with only a 10% shave, still like 99.7% about the total load is still going to the Geo system. So there's not much change in the annual energy from the Geo hybrid systems. But if we start changing the shaving a little bit, we can see how that relationship is played out graphically. This example, the peaks are 100% Geo, 0% hybrid, total is 100% Geo, so we just have these two, like what we looked at. If we slide the slider 10%, so the peak is 90% Geo and 10% hybrid, the total load is still 99.8% Geo, and only 0.2% of the load annually is going to be going to the hybrid system. You can kind of see that graphically. If we switch to the slider to 20%, where 80% of the peak is covered by Geo and 20% is covered by hybrid, we still see that 98.7% of the load is still going Geo. The hybrid system is only going to be on approximately 1.3% of the time, because it's only dealing with 1.3% of the total load. If we continue down this process where we do a 30% hybrid slider, where 70% of the load's Geo and 30% is hybrid, we still see that 96.3% of the load is still Geo. The hybrid's still very, very rarely used. But you might be looking at this and thinking, well, I can save the loop field installation costs by a heck of a lot by doing this, and the geothermal loop field is still covering 96% of the load. Wow, that's a great idea. This has always been the idea behind hybrids, but now with the new GLD, it becomes very, very easy to quantify and understand what's actually going to be happening. If we slide the slider to 40%, where it's 60% Geo and 40% hybrid, we're still at close to 92% of the total load being Geo. If we go to a 50-50 peak shave, the total load is still 84% Geo. The hybrid system is only covering 16% of the load. And we can continue down this path, so we go on and on. So for example, if we slide the slider to 70%, where only 30% of the peak is Geo and 70% is hybrid, the Geo system is still covering 60% of the load, and the hybrid is only covering 40%. It's only really when we get to basically 20% of the load being, 20% of the peak being Geo and 80% of the peak being hybrid, that the hybrid system starts dominating over the annual energy. In this case, the hybrid system is representing about 56% of the total load, and the geothermal is about 43%. But it's still almost even. And then we go to 10%, Then we go to 10% geo, 90% hybrid, and we see that in this case the hybrid system's covering about 3/4 of the total load. And then if we go 100% slider, where geo is 0 and hybrid's 100, we see the hybrid system's covering 100% of the load. And this is kind of a graphical representation of those different slider ratios. Like this is a monthly temperature profile data that's generated from the borehole module. We see temperatures on the y-axis and months on the x-axis. This is what, 15 years, give or take, 15-year simulation. And it's really hard to see, but when we have 0% hybrid, where it's 100% geo in this cooling dominant system, the temperatures just creep up and up and up and up. As we go to a 10% hybrid system, we see the temperatures creeping up and not quite as much. So go to a 20% hybrid system with the green, you see the temperature still creeping up but not as much. And as we get to like 50% hybrid, you see this orange line, the temperature is still creeping up but not as much. So when we reach 70% hybrid, where basically the peak is only 30% geo and 70% hybrid, so we see basically a very balanced system. You see this pink line here where it's basically flat year after year after year. At that ratio for this particular profile, 30% geo peak, 70% hybrid peak, where the annual energy being exchanged with the ground is roughly equivalent, and therefore you get a balanced system there, which is, you can save on your installation costs, performance goes up, there's a lot of benefits to that in that example. And then if we do 100% hybrid, for example, where there's no geo at all, suddenly it's basically a heating-only system because the cooling load's all being covered by the hybrid system, and then the temperatures drop and drop and drop because it's just a net heating system where you're sucking energy out of the earth year after year, and the temperatures drop and drop and drop. So you can really very quickly do these kind of models and analysis. And this is sort of a graph. This is graphed in Excel, but the data become available when you do a simulation in GLD for use in Excel or whatever spreadsheet you want to use. Again, we have our original cooling loads in blue. And then after we do the hybrid design, we have the geo-cooling loads in red. You see how it's been flattened here, decapitated, peak shaved. And then the hybrid loads are in green when they come on. So you can kind of just see hour by hour what's going to geo, what's going to hybrid. And then this is just the same graph, but basically just hybrid loads stacked on top of geo loads, just another representation of the same information. So now let's actually look at the software in action. Here we have the GLD 2014 software, and I'm going to first start by actually doing a couple samples with that hybrid tool, kind of illustrate how it works and how quick and easy it is. And then after that, we'll look at some of the other features. So I'm going to open up a new average block loads module. I'm going to start with, say, a fresh design. And I'm going to hit the Add New Zone button. So I have a new fresh zone here. Now I'm going to import an hourly loads profile first. Hit the Import button. I can go to my hourly data files. I'll just choose this one. This is for about a 40,000 square foot office building in Denver, Colorado. See, the cooling peak is about 755. The heating peak is about 810. So based on the peaks, it's a little bit heating dominant. But if you look at the annual energy, annual equivalent hours, the cooling hours are quite a bit higher than the heating hours. The net load is cooling dominant. I can look at the monthly loads here to kind of look at that hourly profile month by month, see what's going on. And the take home here is my total cooling load is about 478,000 kBTU. My total heating load is about 370. And then if you think about the heat of compression to be factored in as well, then it's certainly cooling dominant. So I'll choose a heat pump. I'll just choose for water furnace for this example, just because it's the bottom, it's the very last one on the list, so it's quick to select. I'll choose a 4-ton 5 series. And then what I'll do is open up a borehole module. And I'm going to link them together. And I'll just start a preliminary design. Well, one thing to note is actually, if you were looking down here a moment ago before I linked, there were actually 4 tabs here. 4 sliders, a peak cooling slider, a total cooling slider, a peak heating slider, and a total heating slider. There were 4 of them there, and now there's only 2. The reason why there's only 2 now is because the program recognized that hourly data is in use, and the program can basically do all it needs to do with only 2 sliders rather than 4 with hourly data. But I'll come back to that in a few minutes. So I'm going to start a preliminary design. I'm going to assume all my inputs are okay. Hit calculate. And I get 50 boreholes about 300 feet deep. My inlet temperatures are 90 and 40. And this is like a preliminary design that I'm happy with for the time being. So I'll go to my monthly profile, monthly mode. And I want to see what happens month by month to the fluids in the system. So I hit calculate. And I see the temperatures come up here, 80 and 50, a little more moderate than the design day because the system is fairly balanced. And we graph the data here. What I see is it's a pretty reasonable design overall, but there is a bit of a temperature creep. It is cooling dominant. When you take the heat of compression into account, temperature is creeping up a bit. Nothing really to worry about in this design. But let's just see what happens if we start playing with hybrids. So I'll bring the peak cooling slider over. I'll bring it to 20%. You'll notice this update button turns red. What I have to do now, as opposed to previous versions of the software with the hybrid tools, you have to hit the update button. When you do that, this module, the average block loads module, indicates we're looking at hybrid loads now, and the loads have changed. See, the peaks here and the total annual energy has changed. I'll reset it so you can look at that again. Here's the original loads. Now if I put this at around 20%, and hit the update button, everything changes here. If we look at the monthly loads, we can see that where the peak decapitation has happened, it started in the month of May and gone through September. See how these are flat here. So these months have been affected peak-wise, and they've also been affected on the annual level. The other months of the year, this winter and early spring and fall months, haven't been affected at all by this particular design. If I want, I can graph the data to kind of look at what's going on. This is one of the new features, one of the new graphing profiles, controls. And what we can see is we see cooling data and heating data. I'm going to get rid of the heating data because we're only looking at cooling for the time being. So I have my geo total load, my total geo cooling loads here. My geo peak is here. You see how it's been flattened here. And this flattening goes hand in hand with the flattening we see here at the 605 level. And then our peak for the hybrid systems here in this green dotted line. And our total load for the hybrid is down there, not much, a few percent. If we want to say, what is the actual percentage of the load going hybrid, we have this button here we can push, called the summary button. And this summary button kind of summarizes the relationship between the geo and hybrid system, both on the peak side and the total side for cooling and heating. So for example, on the peak side, the total load is 755. The geo component is 80% because we slotted the slider to 20%, or 604. And then the hybrid is 20%, or 151. Then on the total side, the total load was about 478,000, which is 100% of that total load. Geo's covering 98.7%, and the hybrid's covering 1.3%. So this little area under this curve here is about 1.3% of the total load, and then everything underneath here is the other 98%. So you can really see we've spliced the peak 20%, but we're still covering almost 99% of the load by geo. It's a pretty good trade-off. You're going to save a fair bit in your installation costs, but you're still going to be basically 100% geo, and the hybrid's almost never going to be on. So let's look at the graph now of the 20-year simulation to see if this has flattened the graph out. It's still creeping up. What happens if we go to, say, a 50% hybrid? I'll go to 50% hybrid, and let's look at the loads. And then I have to hit the update button, and the loads will update. So the loads have updated. Now let's hit calculate, see what happens. See what happens to these temperatures. They're going to drop, but let's see if they've stabilized and flattened out. Let's graph it to see if it's flat. It's getting flatter, but it's still creeping up a bit. So the net load is still, with the heat of compression, still slightly cooling. So then I can do the summary panel, and we see this is why then the load is still creeping up. And on the total side of things, geo is still covering 84%, hybrid's only covering about 16%. So the majority of the load is still going to the ground loop. If I go up to 70% here, hit update. My loads are going to update. Hit the summary button. Now I picked about a 60% of the total loads geo 40 hybrid. It's getting close. You can hit calculate, see what happens to these temperatures here. These temperatures continue to drop because less and less, I haven't changed my loop field size. It's still 50 boreholes, about 300 feet deep. But the amount of load going to it keeps decreasing, so the temperatures keep getting more and more moderate. And at this point, it looks pretty even now. It looks like it's pretty well flattened out. Not exactly, but close enough. So you as a designer might say, okay, this is sort of my sweet spot for this design. But I certainly don't need 50 boreholes anymore. Why don't I switch from 50 boreholes to 20 boreholes? So in essence, I'm going to shave, 60% of my loop field away. Hit calculate. Now my temperatures are 70 and 34. So, 79 and 34. It's gotten, a bit more extreme, but it's still very, very beautifully balanced because the load is balanced. And so you can see what we did essentially in a nutshell is I figured out I could basically, if I do a hybrid design where 60% of the total load is going geo, so it's still the majority, 40% is going hybrid. If I set a system like that, I'm able to reduce my loop field by 60% while increasing performance, and 60% of the load is still going geo. So it's a pretty nice trade-off you're getting here. You're shaving your peak, you're covering 60% of your total load, still geo, but you're cutting 60% of the loop field. This is one of the functions of the new GLD. It makes it very quick and powerful for doing this kind of an analysis. So that's basically how you can use this with the hourly 8760 loads profile. Now we're going to look at briefly what happens if we don't have that data, if we only have monthly loads profiles. So I'm going to close everything down and just sort of reopen it so we can start from scratch. So open up a new average block loads module. I'll add a zone. This time I'm going to import a monthly loads profile. Let's find the monthly data. So I'll import a train trace file, a geothermal template file from the train trace program. We'll do this, cooling for course. It's a pretty heavily cooling dominant system. I'm going to select the heat pump again. This time I'll just choose the carrier piece of equipment. Choose this one, for example. It doesn't really matter for the example I'm going for here. I'll open up a borehole module. I'll link them together. Now you notice that now for the hybrid design controls, there are 2 sliders for cooling and 2 sliders for heating. Previously, there was 1 for cooling, 1 for heating. The reason for the difference is this. With hourly data, the program has enough intelligence to figure out exactly when things are going to be shaved and split between geothermal and hybrid technologies. However, with monthly loads, there's simply not enough data available in these loads profiles for the program to know exactly when things are going to be shunted on the peak and the monthly levels or total levels. So you have to, as a designer, you have to have some control to do it manually and make your best estimate, essentially. So for example, let's do a preliminary design assuming 100% geo here. I'll just hit calculate. So we have 50 boreholes, 182 feet deep, kind of shallow. Why don't I switch to maybe 30 boreholes, see what happens. 300 feet deep. I'll reduce the spacing to 20 feet. So my system has 30 boreholes, they're about 320 feet deep. Predicted ground temperature change is a hair under 5 degrees. It's kind of borderline. So I'm going to decide, okay, I want to do a bit of a hybrid system here. So I can say, okay, I'm going to start with a 10% peak shave. And for the total load, I've seen in samples previously that, it's not a 1-to-1 ratio. Typically, I slide the peak 10%, maybe the total is only a few percent. So I'll slide the total by 5% just as an example. Hit the update button. These both change. Pump selection's updated automatically. Hit calculate again. So now it's dropped to 284 feet. My ground temperature change is reduced to about 4.2. Maybe I'm thinking I want to get down to 250 as an example. So maybe I bring this up to 20%, and then maybe I bump this up to maybe 8%. Again, we don't really know with great detail the relationship between the peak and total load with only a monthly profile. There's no way to ascertain it unless you have hourly data, but we're just taking our, an estimate, a guess, essentially. Hit the update button. The loads are updated. You calculate again. Now I'm closer to 250. Ground temperature is a little more reasonable. Now I'll say, what happens if I do a monthly simulation on this case? This is another nice feature in the new version of GLD. In previous versions, Anytime you switch modes from design data monthly to hourly, all the hybrid designs you'd put in would be reset to 0 and you have to regenerate them. Now they're just locked. It's very, very convenient. Now I can calculate for this design to see how the system is going to play out month by month over 20 years. And this is interesting. The monthly profile is basically telling me I have something to worry about here. The design day method, which we consider to be, in many cases, very straightforward, fast, using minimal data, sometimes it can miss things. The monthly design here is predicting that the temperature is really going to creep up to perhaps an unsustainable level. So based off of this information, I may decide, okay, I want more of a hybrid system. Maybe I want to slide my peaks up to, maybe I want to go to 40% peak. My 40% of my load will be peak. 40% of my peak load will be hybrid, 60% geo. And then my total, maybe I'll put this at around, 16 or 18%, just a guess, essentially. Since there's not enough, since we don't have hourly data, we just have to take an estimate. Hit the update button. I've changed all these. Now I can calculate again, see what happens to these temperatures. So 150 is certainly more reasonable. Graph it out. It's still, creeping up, and then you see it starting to stabilize. So you as a designer can keep playing with these options until you get what you're comfortable with. Again, the big difference here on the monthly side is that now you have these two sliders you can control for cooling and for heating. Well, you only had one before. Just gives you a finer degree of control and potential accuracy. But in this example, let's just do one more to try to balance it out. What if I go to 50% here, then maybe on the total I go, maybe it goes up to 25%, something like that. I'll update the loads. The loads have been updated. It's still very cooling dominant on the total energy. As we can see here on the monthly profile, we have basically decapitated the loads here, here, and here, and here in these months. And these have been cut as well. But we still see it's still very cooling dominant. And if we graph it out, you can see that as well. I'll just look at the cooling information. So I see my peak here. My geo peak has been decapitated at this point. My hybrid peak's right here. So because it's at 50% here, the peaks are equivalent essentially at the top. But on the total load, this is the geo load, this is the hybrid load. You still see it sort of like maybe a 2-to-1 or 3-to-1 ratio, so it's not it's not balanced yet. You could also hit the summary button again to see that balance. 77% geo, 22% hybrid. So when I when I hit calculate, I expect basically the graph still to be trending upward because it's not really balanced. If I do want to balance it out, maybe I'll want to do something like this. Maybe it'll be, say, let's try 70% geo, and then let's try 50% here and update it. Summary. Now it's close to balanced. It's very close to being balanced here. Now if I do my analysis, do my calculation, these temperatures will drop a lot if the load's balanced. And then as I do my graph, it should be relatively flat compared to what it was before because our load is pretty well balanced. You kind of can see how this tool can work. Now the key to understanding this, though, for the monthly data only is these peak and total sliders. The total slider is something that you are controlling as your best estimate because you don't really know with only monthly loads. With hourly data, like we saw in the previous example, we really have a good idea of what's happening hour by hour, so we can figure things out with a great deal of detail. With monthly, it's an estimate, but you have to estimate what the impact is on the total loads. So there's a little burden on the designer to do their best bet. A lot of advantages to hourly data. In any case, that is basically an introduction to the new hybrid design tools in GLD. A couple minutes left to show you a few other things before I open this up to any sort of questions people may have. A couple other things that are new in this module, in this program are, first off, if we go to the YouTube tab here, we have a whole new database of international pipe sizes. And in many parts of the world, as you may know, the inner diameter, outer diameter relationships are different for SDR, depending on where you are. So now we have international database. Anything that says OD is basically the SDR. For example, SDR11 OD is the international, SDR11. SDR 13.5 OD is the international. And we have this integrated throughout the entire program. Another thing that I think is pretty neat is it increases the accuracy quite a bit in this module. This is the fluid dynamics module, which is really, really, really powerful for quickly designing your piping system once you know how many boreholes you need in the ground. So for example, we know we need 30 boreholes, 255 feet deep. But the next question is, how do I set that up so it's going to flow with the least possible circulation pump requirements while providing me with the turbulence? And at the same time, how can I ensure I can purge it easily? And this module essentially answers those questions very, very quickly. And what's new, there's a lot of new things in the background in this program for, speeding things up, improving the optimization. But from a design perspective, the designers have control of, we have this new database in here where essentially you choose a fluid, say that's using propylene glycol, then you choose a freezing point. Well, let me choose a different, let's go back here. Well, as you can see, it says no data available, and this is is a bug in the program. That's why we haven't released the program yet, because we're still fine-tuning it. Let me see if I can get a different fluid here. Anyways, I don't think I'm going to be able to show this result, but I'll try to explain it because the screen's popping up. Basically what you do is you choose a new type of fluid. You choose your fluid, whatever it's going to be, then you choose a freezing point protection. So in this example, well, we probably wouldn't need any freeze point protection in this example. But let's say the minimum heating temperature was expected to be 35 degrees or something. So then you might want to have freeze protection down to 25. Oh, here we go. Look at this. Now it's working. So I choose propylene glycol with freeze protection down to 25. But then you don't expect the temperature to drop to 25. Then you choose your minimum expected temperature. Maybe it's 32. Then the program determines the viscosities and specific heats, etc. For this type of fluid at this temperature. This is the new thing, choosing a design temperature based on a fluid selection. And this does affect your calculated head loss and metals numbers, typically in the range, I'd say the accuracy improvement somewhere between, and a typical design, between 8 and 10%. So there's a decent improvement here with this more advanced solutions database that we have in the program now. So it's that, if you're able to reduce your circulation pumps by 10%, over the course of a lifetime, it does add up. So this is just an increase in accuracy. Those are some of the major new features. We've sort of run out of time here, and I'm going to open this presentation up to any questions that anyone may have about anything we've talked about today. So if anyone has a question, feel free to just raise your hand. There's a little button you can push to raise your hand on the user interface. If you cannot find that button, feel free to just unmute your mic and then ask away. Okay, so it doesn't look like there are any questions, so I'll just show one last slide while participants have an opportunity to think about if they have any questions. And the last piece of information here is we're expecting to release this software in approximately 3 weeks. We're in basically final QC right now. As you saw, we still have some bugs we're working on, but that's inevitable with complex software. And GLD is available for pre-order now at a discount rate through the end of this year. So through December 31st of this year, will be available at a discount rate. We're expecting the release to be in 3 weeks. So if anyone's interested in pre-ordering at this discount rate, what will happen is you can place your order through Groundless Design, and then we will basically update your license key, your USB key now, and then as soon as the software comes out, you can download and start using it without having to wait. So any questions from anybody? Questions, comments? Okay. Oh yes, I do have a question. So our Sanders, Mr. Sanders, or Mr. Sanders, I'm not really sure. What's your question, please? Unfortunately, I wasn't able to hear your question. Could you, there's a chatting function. Is there any way you could chat your question? Type your question? Okay, got it. Okay, the question is this. I see a GT file folder. GT stands for Geothermal Template Files, presumably from loads calculated with the train trace program. What did you use to create your hourly loads file? Was that exported from trace as well? Okay, so the question is, where does hourly data come from, essentially? And the trace program does have the ability, the trace program does use hourly data, and there is a way to export hourly data from the trace program. So certainly if you use trace, you can get the hourly data. If you use the Carrier HAP hourly analysis program, you can get the data. If you use Equal, those energy simulation based on hourly or shorter time steps. They all have access to this data that we can use inside of GLD. That's one question. So the next question basically was an interesting question. Well, they're all interesting questions. Is these controls, basically our controls are determined in terms of systems of load, but actually the systems are controlled on loop temperature. So this is a question related to basically control of the system, when it's actually operating. And my answer is GLD at present time is designed for designing and sizing loop fields, and not necessarily in terms of the advanced control and the operation. And so really they are controlled by temperature. When a fluid temperature reaches a certain point, and then the hybrid system kicks in, and that's a very reasonable way to do it. But what we're using GLD for at this point is really predicting what's going to be the minimum, essentially the optimal loop field size to give you the predicted temperatures that you want, and then based on the hourly profile when you expect the hybrid system to kick on, meaning the temperatures in the ground loop are going to be at a point where that hybrid system is going to kick on. You design your loop field using this tool. You basically figure out what temperatures, you think about what temperatures you want your hybrid system to come on. You size your loop field for that, and then at that point of time, based on the hourly data, you can figure out what the hybrid system is going to come on. But we are not specifically, a software tool at this point for designing control strategies, although you can use it in that way to essentially do what you're trying to do. And then another question. Have you thought about how to control the hybrid load by loop temperature instead of percentage there? It's exactly the same question. So obviously this is a topic of interest, and really, yeah, certainly we could do that. It would take a while to do the calculations, but thank you for those suggestions. Now we have two people asking the same question. Probably means we should look into adding it in. Okay. Yeah, it does. It does have a big impact on sizing, but you can basically reverse engineer it for, Brian, you can reverse it using the GLD 2014 with hourly data. You can reverse engineer it to get those temperatures that you want, essentially, as we just saw. It's not quite as easy as designing specifically, specifying a temperature than doing the load splitting, et cetera. That's kind of the reverse of what we have right now, but you should be able to back into what you're looking for with what we have with this new version, I think. So two good questions, several good questions. Any other questions about anything? Another question. Okay. So what is your typical target max temperature entering water temperature? Fluid cooler doesn't really work until there's a delta T with a loop temperature higher than ambient, so 85 is unreasonably low target, but perhaps 95. Yeah, a lot of people do a lot of different kinds of things. I would say typical, when people are designing typical pure geosystems, typical range of targets entering water temperatures is probably in the 85 to 95 degree range. Some people aim for 100, some people aim for 75, but the most common is probably 90 degrees plus or minus 5. But if you're working with a hybrid system intentionally, and the hybrid system is going to come on, you have some more flexibility in terms of what you're aiming for. Maybe you do want to aim for, a little bit higher. Of course, the higher you aim for, it is going to reduce the performance of your system. Okay, a lot of good questions here. So I got a question. What is the price of GLD 2014? And this is actually later today, this afternoon, we're going to have a pre-order page ready on the Ground Loop Design website. But the upgrade prices through the end of the year for current 2012 users is $600. After the first of next year, it's going to go up to $800.
Cool.
New prices are going to be very substantially similar to current prices. But as of the fact there are many people in this webinar, some are using GLD 2010, 2009, 2012. The prices are going to vary depending on what you're upgrading from. But from 2012 to 2014, it's going to be $600 through the end of the year. Yeah. So another question. This is I noticed that there's a big difference in the entering water temperature profile when you run design day or monthly simulations. What's your comment on this? We actually offer 3-hour classes that kind of go into detail on that issue. But to briefly answer it, when you do a design day simulation, we're using basically 10 data points, 10 loads data points, design day data points. When you're doing a monthly simulation, we're using 48 data points. So we use a lot more data. In addition, it's a different heat transfer model. It's sort of a numeric model versus an analytic model. And for those two reasons, the model that we're using and the amount of data we're using, we get different results. The challenge for designers is to, basically understand the difference between those two results and come to a design that they're comfortable with. And we spend a lot of time in our online training kind of explaining recommended processes for doing that. And if you are interested in some of those training options, you can just go to the Ground Loop Design website and find out about that as well. We offer those webinars basically once a month on a regular basis. Any other questions about anything in the software coming out in the new stuff? Doesn't look like it. If anyone has any follow-up questions, feel free to contact groundloopdesign.com or call us. Thank you very much for your time this afternoon listening to us introduce the new features. And we're very happy to have you here today, and thank you very much. Really appreciate it.